This is part 3 of section 11.3. So let's say there are 14 standbys who hope to get seats on a plane, but only 6 seats are available. So how many different ways can the 6 people be selected? Now, we're not being asked to find how many different ways we can assign 6 seats, where it would matter who sat in which seat. We're being asked how many different ways can we just pick the 6 people? So that makes it a combination because the order doesn't matter. If we were asked to assign seats, then it would be a permutation. Okay? There are 14 people to choose from, and we need to choose 6 people. So this will be 14 factorial over 14 minus 6 is 8 factorial, 6 factorial, which you can enter into your calculators to get 3003. So there are 3003 different ways for us to choose those 6 people. Okay. Now, we're going to use the formula, the combination formula, along with the fundamental counting principle to solve the following problems. Now remember, the fundamental counting principle was what we did in the first section of this chapter, where we did things like calculate the number of outfits you could make. So if you had 2 shirts and then you had 3 pair of pants, you multiplied those together to get 6 different outfits. So that's where we're heading. Okay, how many different committees can be formed from 5 professors and 15 students if each committee is made up of 2 professors and 10 students? Okay, when we first did the fundamental counting principle, we were using every single available object, and we're not doing that here. Okay, what I want to do first is I want to count the number of different ways we can find professors. Okay, we have 5 professors to choose from, and we need to pick 2 professors. So this would be 5 factorial over 3 factorial 2 factorial, and this is 10. So there are 10 different ways we can choose the professors to be on this committee. Now we're going to do the number of ways to pick the students. Okay, we have 15 to choose from, and we need to choose 10 of them. So this is 15, C10. So this would be 15 factorial over 5 factorial, 10 factorial. Which is 3003. Okay, so now it's like, well, I'm just got to pick one of my combinations of professors. I need to pick one of my combinations of students and put them together to form a committee. So now that we know the number of ways to do this, the number of ways to do this, now it's where the fundamental counting principle comes into play, and we multiply those together, the number of ways to pick a committee. Would be 10 times 3003. So 30,030. Okay. This is a similar problem. The U.S. Senate of the 109th Congress consisted of 55 Republicans, 44 Democrats, and 1 independent. How many committees can be formed if each committee must have 4 Republicans and 3 Democrats? this is essentially the same type of problem. We've changed the details, but still we need to pick Republicans from the number of Republicans. So I need 4 out of 55. So 55C4 is going to tell me the number of ways I can pick the Republicans to be on the committee. And then out of 44, I must choose 3. So this will be the number of ways to pick the Republicans, the number of ways to pick the Democrats, and then I'm going to multiply those together. Okay. 55C4 is big. Okay. And then the number of ways, 44C3. Okay. Now the number of ways to form the committee total, I multiply these together. Okay. Okay, so that's what I'm about to copy down here, hopefully correctly. 4, 5, 1, 6, 9, 3, 2, 4, 2, 0. Double checking, and that's correct. So there are 4,516,932,420 ways to form that committee.